Okay, so can I have your attention for about 3 minutes, and then I'll let you loose on these questions for me. So, if you remember yesterday, what were we doing? What were we doing yesterday? Good, so we started on the theme probability. And specifically, what were we looking at? What were we doing yesterday? Yeah, we were looking at ordering things and arranging things and basically just counting the number of ways of doing things. So counting the number of outcomes, okay? The number of ways of doing certain situations, right? Now, why did I say this is important? This is important. Specifically, why is it important to do with probability? Absolutely. So can anybody remember the fundamental way of working out the probability of an event happening, the theoretical probability of an event happening?
Outcome of interest.
Yep.
Over total outcomes.
Good. So it's the number of outcomes that you're interested in divided by the total number of outcomes. Okay? And I said, well, you know, if you're looking at a situation, for example, with rolling a dice or a die, this is fairly straightforward because it's quite easy to know the total number of outcomes, 6 possible outcomes, and it's easy to count the number of outcomes of interest. But when you have slightly more complicated situations, you need strategies in order to count the number of outcomes that you are interested in. And this is what we were looking at yesterday. So how could we come up with strategies to count the number of ways of things happening? Okay? Now, I think we looked at 3 fundamental ideas, okay? So first of all, if I had n objects and I was going to order them in a line, how many ways are there of ordering n objects? Can anybody remember? Good, so it's this idea of n factorial. Now, what's n factorial again? Just remind me. Good. Yeah, exactly. Perfect. So it's basically you multiply by successive numbers. So if it's 5 factorial, it'll be 5 times 4 times 3 times 2 times 1. Okay? N factorial, you just basically multiply by successive numbers. We happy with that idea? Okay? So it's the real fundamental idea of working out how we can order objects in a line. Okay? How we can work out the total number of outcomes, right? And then we just basically built on this and looked at different situations. Okay? So, for example, boys, you paying attention? Boys, in the corner? Okay. So, first of all, okay, the first one we looked at was when we had repeated objects, okay? So we had to make an adjustment of n factorial when we had repeated objects, okay, repeated objects. So, for example, if I give you the word statistics, I think this was an example we looked at yesterday. How many distinct arrangements exist of statistics? Perfect, yeah. So you said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different letters. Am I counting that right? Yeah, 10 different letters. So therefore, ordinarily, there would just be 10 factorial ways of arranging these 10 letters. However, because we have repeated objects going on, repeated objects, you've got 1, 2, 3 repeated S's, right? Which means that if you swap the order of the S's round, you're not going to notice because it's no longer distinct, okay? So therefore, you need to get rid of the number of ways where you just swap the S's around, okay? And then you say, well, hang on a minute, there's also 3 T's. So if I swap the order of the T's around, I'm not going to notice, so therefore I need to remove those from this number of ways. And then also you've got 2 I's. Yeah, so you're also going to need to divide by 2 factorial ways of arranging those 2 I's. Good, exactly. And then we looked at certain different arrangements. For example, what happens if, say, for example, an S and T has to be together? Or what happens if 3 letters have to be together, right? And then we looked at conditions like that. Now, spoiler alert, we're going to look at some more conditions today, okay? So this is why I've given you this sheet, okay? So there's some more conditions on here. But at the end of last lesson, we came up with two fundamental formulas, okay? One of them was to do with ordering, okay? So when order matters, when you just want to order objects in a line, so say, for example, if you had 10 objects to choose from, but you didn't want to order all of them, you only had 3 positions to put them in. So you only wanted to order 3 of these objects from the possible 10. How do we do that? Anybody remember?
Factorial 10.
Yep. So let's say n factorial, let's do generally. N objects, and we're choosing r of them. So we're ordering r of them. Yeah, go on.
So the 10 multiplied by 9 multiplied by 8.
Exactly. But you only want to order r of these objects. So say 3 of these objects.
So 3. So yeah, we can stop at 8.
Good. So in other words, you're saying, so say for example, let's do it with the example, okay? So I have 10 objects. Okay, I have 10 objects, but I only want to order 3 of them. I only want to order 3 of them. So what you're saying there is it's going to be 10 multiplied by 9 multiplied by 8, yeah? Because there's only 3 objects, so 10 objects that go in the first position, 9 objects can go in the second position, 8 objects in the third position, okay? But then we generalize this because we said, well, this kind of looks like a factorial, except it kind of stops, right? It starts off like 10 factorial, but then it stops when we get to the 7 factorial bit. So the way which we dealt with that is by getting rid of it. So we said it's n minus r factorial. Is that okay? Yeah? Now, can anybody remember what notation did we give to this? So if it's an order, another word for an order begins with a P. It's a permutation, okay? So we say it's a permutation. How many objects did we start with? N. And how many objects are we choosing? R. Okay, so NPR would be equal to this. Okay, it's this kind of idea here. We all happy with that? Okay. But then the second situation we looked at was we said, well, hang on a minute. What if we didn't care about order? What if we only wanted to choose those objects? So we didn't care about putting them into a line or anything like that. Okay. How do we adjust this formula? Can anybody remember? Divide by r factorial? Yeah, absolutely. So you basically take NPR, you take this thing, and you just divide by that r factorial. So in other words, this thing, if you take this thing, n minus r factorial, and if you divide by r factorial, it just ends up there. Okay, just think about your fractions. Does that make sense to everyone? Why did we divide by r factorial? So let's say, for example, we weren't caring about ordering these 3 objects. Let's say we only wanted to now choose these 3 objects, okay? Why do we have to divide by, in this case, 3 factorial? Why do we have to divide by that 3 factorial? Exactly, yeah. So you just think about all the different orderings you can have of these 3 objects, 3 factorial ways, and you just say, I don't care about them anymore. So you get rid of them by dividing them. Does that make sense? Right? So you have to divide by that. This we gave a special name when it's a choose. Can anybody remember? It's a combination, perfect. So it says NCR, C for combination or choose, okay? Or another way of writing that, we can write it as a vector, like this, okay? So if you see that going on in probability, it simply means N choose R. Simply means we start off with N objects and we only choose R of them. Does that make sense to everyone? Okay? So the distinction between these two things, this thing is when we want to actually order things, for example, in a line, okay? This is when we just want to see, well, hang on, what if we just choose them? We don't worry about order. What if we just wanted to choose them, okay? So in general, which number is going to be bigger? The number of different orderings or the number of different combinations? The ordering, perfect. You're happy because the combinations, you're getting rid of a lot of these orders, yeah? Does that make sense to everyone? So that should always be bigger than that in general. Is that okay? Good, fantastic.